Scatterplots and linear model skill practice. Let's go start with number 6. This graph was based on head counts of the Gary Ivy Tech region from 92 to 2011. The graphic also includes a trend line model from this data. Now, do notice that the years are actual years. So when you plug in for X, you will plug in the actual year. That's important to note. Okay, so part A. Let's find the trend, use the trend line equation to estimate the enrollment for 2009. So 2009 is here. This is the actual value, right? And here's the trend line. So the estimate. So we're going to plug in 2009. So y equals 178.09 times 2009. After you have that answer, you're going to subtract 353,194. And when you do that, you should get an estimate of approximately 4589. And that makes sense. I mean, if you look at where it's at, it's about right here, which is just a little over 4,500. And this is the estimate. Now, how does that compare with the actual value? Well, remember, look at this. The dot is the actual. Here is the actual. Here is the trend line. So the actual is higher than the estimate. You didn't have to find the estimate to know that. You could have just looked. The actual dot is higher than the estimate. It is on the graph. It is. State the slope of the trend line. Well, the slope is in front of X. So the slope is 178.09. I'm going to put it over 1 because slope is easiest over 1. The dependent variable is on top, and this is head count. The independent variable is years since 1992. So to interpret this meaning, head count at Ivy Tech Gary has increased, and I know it's increased because it's positive, has increased 178.01 people per year since 1992, right? Head count's positive, so it increased per 1 year since 1992. I like to put my labels on here so I know exactly what I'm talking about. Calculate R and explain its meaning. Now, you'll see on the graphic that you have R squared equals 0.7869. Well, to find R, we square root both sides. So R gives me 0.8871. Well, what does this mean? Well, it's not super close to 1, but it's pretty close to 1. So we would say there is a strong positive, and we know it's positive because if you look at the graph, it goes up, right? That makes it positive. So there is a strong positive linear correlation between head count and years since 1992. It goes up, so it's positive. It's decently close to 1, so it's strong. And between the two variables, right? Independent and dependent variable, which would be head count and years since 1992. All right, let's move on to a new one. We're going to use a scatter plot to answer the following questions. Now, what is the independent variable? Well, the independent variable is down here, and we'll use the variable x, and it represents the number of class days attended. And it looks like, here's 25, it's 1 dot pass, so it looks like 26 is the max number of days you can attend. Just FYI in case we need that later. Hint, hint. All right, oh, shoot, look at that, part B, 26. I knew it was there somewhere. 26, because 25, there's 1 dot pass. So we can have 26 days of attendance. What is the dependent variable? Well, dependent variable is here, and it's the class grade as a percent. So grade as a percent. State the trend line. Well, on that graphic, you see 3.9352x minus 12.702, right? That's the trend line, or they call it a linear regression line as well. Write a sentence explaining the slope. Okay, well, slope is the number in front of x, so 3.9352 over 1. Dependent variable goes on top, so this is the class grade as a percent. I should put grade, not class. Grade as a percent over, and this is number of days attended. So the grade as a percent increases, and it increases because it's positive, increases 3.9352% for each day attended. right? The more you attend, the higher your grade. That makes sense. Use the R-squared value to determine the R valuable, and then is this reasonable? So we're going to say we have R squared as 0.8245. We square root both sides, and we get an R value of 0.9089. Now this means strong, positive, linear correlation. Is it reasonable for this data? Well, let's go back to our graph. Now when you're looking at this graphic, 0.9 says there's a really strong positive linear correlation. I don't know if it's reasonable. I mean, most of our data is right around here. And, you know, the closer R is to 1, that means the closer our data is to our trend line, because it's really, it's a good representation of our data in terms of being a linear model. You know, our data is not super spread out along the line. It's very, very concentrated there towards the top. And that is close to the line. So is it a good representation? I don't know. Maybe, maybe not. I mean, I think it's kind of an opinion question, but whatever. Your classmate anticipates being on vacation in the middle of the semester. She's going to miss 2 days. So we're going to use our model to figure out, you know, how it's going to impact her grade. Well, we have the model, 3.9352x minus 12.702. Now, if she misses 2 days, remember, 26 was the max you could be. She misses 2 days, she's going to be there for 24 days. So remember, x represents the number of days you actually attend. So we are going to assume that she attends all other class periods. So you multiply these first, then subtract 12. We would estimate she will earn an 82.146. It's going to drop her letter grade pretty much from an A to a B, because it's going to drop it 2 days. It's going to drop it almost 8 percentage points, and that's pretty much what she dropped down below an A. So it is what it is. Now, does attending every class guarantee 100%? Well, look at your model. 3.9352x minus 12.702. If you attend every class, that's 26 class periods. If you plug that into your model, if you attend every class, should only receive a 90.05. So no, I mean, on average, people who come to every class get an A. A 90 is an A, but they do not get 100%. And that's because if you look back at your graphic, there we go, here it is. These are the people who attended all of them. And look, this person got like a 66 or something, and they attended every class period. So no, attending every class period does not guarantee 100%, but it definitely improves your chances because you're going to be there for all the data, right? And that is skills practice for linear models and scatterplots.